Welcome to this lesson on maths, which is titled More Number. The first section is on factors. A factor is a number that goes into another number with no remainder. For example, 2 goes into 6 3 times with no remainder, so 2 is a factor of 3. When we look at factors, we start with 1 and use factor pairs. When you meet in the middle, you have all the factors. We do this for two reasons. Firstly, we don't need to work out if any big numbers are factors unless they actually are. So you don't need to work out that 17 is not a factor of a number, for example. And when you meet in the middle, you know you have them all. Whereas if you just write down the numbers as you think of them, it's very easy to accidentally miss one out or even write one twice. Let's have a look at an example. The factors are 20. We start with 1. The factor pair is 20. The next number is 2. The factor pair is 10. 3 is not a factor, 4 is a factor, and 5 is its factor pair. We have met in the middle because my next number is 5, so we know we have them all. It's useful when working out factors to know some divisibility rules. 2, any number that is even is divisible by 2. That is, it ends in 0, 2, 4, 6 or 8. 3. The digits add up to 3, 6 or 9. The number is divisible by 3. For example, 57. I add up the digits, 5 plus 7, and I get 12. I add up those digits, 1 plus 2, and get 3. I keep adding up the digits until I have only one digit left. My answer is 3, 6 or 9, so 57 is divisible by 3. 4. The last two digits are divisible by 4. For example, 2028. The last two digits are 28, which is divisible by 4. Because we know 28 is in the 4 times table, 7 times 4. So 28 is 7 divided by 4. So therefore it is divisible by 4. 5. The last digit is either 0 or 5. For example, 3065 ends in a 5, so it is divisible by 5. 6 is divisible by both 2 and 3. So we can look at the divisibility rules for that. 42 is even, ends in a 2, so it is divisible by 2. I can add up the digits, 4 plus 2 equals 6, so therefore it must be divisible by 3. We don't actually have to do that to work out whether it's divisible by 6, because we've already done 2 and 3 in our process of working out factors. I've got a factor of 2, a factor of 3, therefore 6 must also be a factor. 9, the digits add up to 9, and 10, the last digit is a 0. Prime factors. Prime factors are prime numbers which, when multiplied together, come to that original number. To work out prime factors, we keep dividing by the smallest possible prime number. So find the prime factors of 252. Well, the smallest prime number is 2. That goes into 252, so I divide by there. That leaves me 126. 126 is also divisible by 2, and I'll keep dividing by 2 for as long as I can, because I always divide by the smallest possible prime number. And that will leave me 63. Now it's not divisible by 2, so go to the next smallest prime number, which is 3. And it is divisible by 3, because 6 plus 3 equals 9. And that will leave me 21. 21 is also divisible by 3, leaving me 7. 7 is a prime number. When I get to a prime number, I stop. So that leaves me with the numbers 2, 2, 3, 3, and 7. So my answer is 252 equals 2 times 2 times 3 times 3 times 7. I can also write that like this. I have two 2's, so I can write the 2 and how many 2's I have as a small number at the top, called an index, times by 3. I have two 3's, so I can write the number of 3's at the top as a small number, times by 7. I've only got one of those, so I don't need to use an index for that. Multiples. The multiples of the number are simply the number in the times tables. So you can see on the screen the multiples of 2. In orange are the multiples of 4. So for example, the first 3 multiples of 7 will be 7, 14 and 21. Prime numbers. A prime number has only 1 and itself as factors. It's useful to know the first prime numbers. The prime numbers below 20 are on the screen. They are 2, 3, 5, 7, 11, 13, 17 and 19. A rectangular number is any positive number that is not prime and not 1. To show that a number is rectangular, all you need is a multiplication statement that does not include 1. So here I have shown 15. 3 times 5 equals 15. That's my statement that does not include 1, so 15 must be rectangular. Squares and square roots. The square of a number is a number multiplied by itself. So here I have 6 times 6. So I have 36 small squares. I can write 6 squared like this. I write a square as a little 2 up the top, so that is referred to as 6 squared, which means 6 times 6, which is 36. The square root is the opposite of a square. So just as addition is the opposite of subtraction, and division is the opposite of multiplication, square roots are the opposite of a square. We know that 9 squared is 81, because 9 times 9 equals 81. So the square root of 81 must be 9, because the square root is what number times by itself will give me the answer. Thanks for listening. Bye for now.